Hello, Concord Junior High students. This is your math teacher, Mr. Rock, with a video. And in this video, you will learn how to solve two variable equations by graphing. Here we go. Okay, two variable equations. This is the definition of a two variable equations. They look like this: y equals mx plus b. The x and the y, those variables represent the ordered pairs, and the ordered pairs are the solutions of the equation y equals mx plus b. B right here, that is the y-intercept. That is the place where the graph crosses the y-axis. And m is the slope. That is how we measure the direction and steepness of a line. Here are a couple of examples of two variable equations. Y equals 3x plus 1. X and y, those are your ordered pairs, and those are your solutions. B is the y-intercept, and 3 is the slope. Here's another example. Y equals x plus 2. X and y, those are your ordered pairs. Those are the solutions. The y-intercept is 2. And the slope, although it looks like there's not a slope, there really is a slope. You have to ask yourself, how many x's are there? The answer is 1. There is 1 x there. So the slope is equal to 1. So in this video, we're going to learn how to solve equations that look like this. And we solve equations that look like this by graphing. And remember, the solutions are all the ordered pairs that are x and y. Here's our first example. We are going to solve this equation, y equals 3/4 x plus 2. And we are going to solve this equation by graphing. And it's not going to be that difficult. The process is rather quick, so pay attention. The first step is we start with the y-intercept. The y-intercept is equal to 2. So I go to the y-axis, which is right here. That's the y-axis. And I'm going to plot a point at 0, 2, which is right there. So that's the first step. The second step is I'm going to use the slope. The slope is 3/4. And I'm going to use the slope starting from the y-intercept, which is right here. The slope tells me how to move in two directions. The numerator will tell me how to move up if it's positive, down if it's negative, and the denominator will tell me how many spaces to move to the right. So the numerator tells you how many spaces to move up if it's positive, or down if it's negative, and the denominator will tell you how many spaces to move to the right. And this movement begins from the y-intercept. So if my y-intercept is 2, that means I'm going to move up 3 spaces, 1, 2, 3. and I'm going to move over 4 spaces. 1, 2, 3, 4. And I'm going to put my dot right there. And that's all I need to do. Well, there is a little more I need to do. I need to connect these 2 points with a line. So my line is going to look something like this. Now I'm all done. I would like to explain to you, though, what I mean by solving this equation and the x, y being the solutions. So let's pick on this ordered pair right here. The coordinates of that ordered pair is, let's count, 1, 2, 3, 4. 1, 2, 3, 4, 5. So the ordered pair is 4, 5. The ordered pair is 4, 5. This is my x value, and this is my y value. I'm going to take that information, this ordered pair, and I'm going to put it into my equation. So my equation is y equals 3/4 x plus 2. X is equal to 4, y is equal to 5, so this becomes 5 equals 3/4 times 4 plus 2. Simplifying the right-hand side, 3/4 times 4 is 3 plus 2. 3 plus 2 is 5. And you can see that the right-hand side is equal to the left-hand side. So this is what I mean by solving the equation. Every ordered pair that this line goes through, every x, every y ordered pair, is a solution of this equation right here. So when we graph this equation, we are actually solving it. Okay, here's our second equation to solve by graphing. Y equals negative 3x plus 7. I start with the y-intercept. The y-intercept is 7, so from the origin I go up 7. 1, 2, 3, 4, 5, 6, 7. So my first dot goes there. All right, so the next thing I'm going to do is I'm going to use the slope. And it looks like the slope is negative 3, but it's more than that. What you want to do is you want to change the slope into a fraction so that it has a numerator and denominator. So negative 3 changes into negative 3 over 1. So from the y-intercept, which is 7, the slope tells me to go down 3 and over 1. So from the y-intercept, which is right here, I'm going to go down 3, 1, 2, 3, and over 1. So my new ordered pair gets plotted right there. So all I have left is to connect these 2 points with a line. I'll try to draw it as straight as I can. That's the best I can do. Again, keep in mind that the line goes through every ordered pair that's a solution. And this graph, this 2-variable equation, has an infinite number of solutions, an infinite number of ordered pairs, x, y, that work in the equation. Last example, 2-variable equation. We're going to solve it by graphing. The y-intercept is -7. So from the origin, I'm going to go down 7, 3, 4, 5, 6, 7. So my first ordered pair is graphed here. The slope is 4/5. So that means from -7, I'm going to go up 4. 1, 2, 3, 4. Then I'm going to go over 5. 1, 2, 3, 4, 5. So my second ordered pair is graphed right there. Now all I have to do is draw a line through these points. That's pretty good. And that line goes through all the ordered pairs that are solutions of that equation. So once again, we are solving this equation, this two-variable equation, by graphing. All right, boys and girls, that's the end of this video. I hope that you learned how to solve a two-variable equation by graphing. Remember the process. You start with the y-intercept first, graph that. Then from the place where you graph the y-intercept, use the slope, the rise over the run, the numerator over the denominator, to graph the second ordered pair. Then connect the two ordered pairs and you have the graph. And before I say goodbye and conclude this video, I would like you to say hi to my kitty, Socks. She is right here. Say hi, Socky. Say meow. That was Socks.